All right, hello everybody. It's going to be hard to fill into the shoes of Minas. He's a very talented person, but I'll do my best. Also, I'm not a robot, as we were promised, but I'm a stand-up comedian, so I hope I can make you laugh a little bit. So let's start with who am I. I'm Georgios Tzafis, recently appointed Chief Commercial Officer of Acumino. I would like to thank Endeavor for this amazing organization for the delegation part, and everything is great, and we get a lot of support. So thank you very much for that. Now, what Acumino is. So Acumino is a company focused in AI robotics, and we'll talk about that a little bit later. Founded by Dr. Minas Larokapis, the guy that's supposed to be here and is so up. And we're a global company. We have offices right now in US, Greece, and New Zealand, mostly of talented engineers and researchers. So whenever we go and we pitch Acumino and we tell them that we build AI models for robotics, the first thing that everybody tells us, oh, it's great, there is a big labor shortage in the market, and we're going to put robots to replace humans, and that's amazing. And we always say, I don't know. I don't think that could be the solution. And why? Because the adaptation right now that we see is about 5% of robots. So is it a sustainable solution? Can we get to 20%? It's very hard. And the reason behind that is that people in the industries do not see ROI easily by placing a robot. What ROI means for these people? Let's make it simple. ROI means high accuracy, don't do mistakes, basically, like a human being will do. Speed, same or almost same speed with a human being. And number 3, be able to do stuff that people do. High dexterity stuff. But let's take a step back. How do you build AI models for robots? And everybody had know about the ChatGPT moment and all the big Gemini releases that they had. So all these AI models, they were able to be trained from the data that exists out there in the web. And yes, there was a lot of work to label the data, to annotate the data, to curate the data before you train these machines, these AI machines. Now, how do you do that in the physical world where the robot operates? And that's where the difficult stuff begins. You need to collect the data out there from the physical world. And trust me, that's not the easiest part you can do. How we decided to do it and what's the innovative advantage that allows us to build reliable AI robotic models is by wearing the robot. And I'll show you more later. Basically, we are able to perform the task, a human being, by wearing our equipment, and then in a very reliable and efficient way transfer the data into our AI models, which eventually will allow this model to become hardware agnostic. And that's what we're talking about key here. It's a key point, because if you want to scale something like that in the industrial world, you need to be hardware agnostic. Let me show you here what my colleague here, Gao, is doing by wearing the robot, exactly what I just described to you earlier. So you see here, Gao is basically wearing a wearable machine, has exactly the same grippers that you see here the robot has on the video. He's wearing a VR and at the same time a backpack that allows him to transfer all the information. And now we get different type of grippers. It's a different task, so you need to adjust on that. So let's see how the robot will perform after Gao showed them how they have to test if the lamp was turned on, that the lamp wasn't set up in the right place, fix it, and then test it on your own that the lamp is working. Let's see what the robot will do. It tests first, understands that the lamp is not on, deploys the fix. Make sure that doesn't break the lamp. These fingers are pretty strong. They can apply a lot of force. Make sure they don't break it, doesn't break the lamp. It works perfectly fine. So that's what we mean about high dexterity. Okay, so I want to summarize a little bit here again what we're talking about, because it can get very complicated. So if you want to play in the AI robotics world, you need to be able to understand the physical world, collect the right data, and transfer them. That eventually will allow you the 3 things that I mentioned earlier. High dexterity, basically what human beings do to perform it as a robot as well. So that's how we become an extension of the human being, and that's how we're able to convert it, the data, and move them. And then speed, if not being as fast as a human being, but being equally fast or close to that. So eventually people can say, okay, that's a task that I can allocate to a machine. And of course, accuracy. And when we talk accuracy, 70%, 80% is not going to cut it. We're talking about accuracies that expand over 95%, 96, 97%. You want reliability when you operate in the industrial automation sector. Now, I'm not lazy, but the robots can do a much better job showing you exactly what we can do. So what we're going to do is we're going to have the robots do the magic, and I will just use my commentary. So this is where we're talking about high dexterity, right? Using a pen as a human being, that's a high dexterity task. You can easily automate that, learn a robot to perform something like that. We can have a robot in the lab setting up very detailed settings on a machine. Doesn't break the machine, it moves very well, it coordinates both arms together. So you can start seeing now applications in the real environment, industrial environment for these machines. Talking about applications. Let's see, that's my favorite example because it's a task that up until now only humans perform. And we are able to show the two robotics arm well coordinated without destroying the box can achieve in pretty good speed. So here we're talking about a pure packing. You make sure you set up the box, you move it on the side, the arm will grab the equipment and place it in the box. All safe and sound. And now this is, for me, this is the most interesting part. Let's go back. Sorry. So let me see if we can move it back. We missed the most interesting part, which was opening the box to fit it in. Or maybe we can play it back later. Now, let's keep seeing some interesting examples. I want to show you something fun that we did for our last Christmas video. This year we are committing to do something even more complicated than knitting. This here task was taken with one shot. Human being showed to the machine for once how to deploy this and basically deploy it. But here you got actually to stop the human beings too, actually. That's what we say when we can become extension of the human. Doesn't break the glasses, put it very nice in the case, close it, and move on. And of course here you see also that they can get very creative. This is also an actual task that came from the industry. Working with cables is not an easy task. All right, that will be for me. Happy to take questions. And again, I apologize, we weren't able to bring a robot here to show you the live demonstration. But if you come here next year, we'll make sure we have it, okay? Thank you.
Thank you.
Hello.
Do the robots have spatial awareness?
Absolutely. So that's why, and I'm not sure if I did this mistake, I used the word models and not model. A robot like that will require various models. One of them is a perception model. It helps with the visual. Right now, it depends what kind of tasks and what kind of environment you want to perform. If you have a robot that's moving on top of a cart, right, then you have to have also autopilot kind of models as well to understand the surroundings. So yes, definitely multiple models, and one of those models is a perception model.
How much faster does the robot, the AI-enabled robot, produce versus the human? Like, do you have some sort of benchmark?
Yeah, I think the question is, you have the right question. I'll tell you how it works. You're trying to get to the speed of the human being. Like, not everybody's quite there. Personally, and don't hold me on that, even if you get 0.8% of a human being, I think it's more than enough because a robot can work 24 hours a day versus a human being. So even if you get to speeds like almost close to a human and you have it deploying there in the background, that'll be, the ROI will come.
Congrats, first of all. I think you put Minaz to shame. He's really good as well. But it's sort of a follow-up to what Georgia just asked, in the sense that we saw a lot of assembly line style robots, right? On the spatial awareness front, do you have movement as well? Are you adding movement to the robots? And then my second question is if you could tell us a little bit about what stage of the enterprise you're at and what you're looking to do in the next couple of months.
Thank you for helping me. I should have mentioned that at the beginning. So about the movement part, right? There are several cobot solutions, basically cards that are moving around with the screen, and they can move things around. And that's definitely very helpful. But we start seeing clients coming to us and say, okay, I can have a cobot to move things around, but can I have the cobot grab things, right? Work on things and then move around. One of the biggest questions we get all the time, bottlenecks in a manufacturing facility being created every day. Can I redeploy a robot from the one task, go to another station because I'm being stuck there? So eventually we are trying to see case studies on that. Definitely that's where the market goes, for sure, right? Now, we are, to answer also the great assist that you gave me, definitely we're looking to get companies that they are focusing in automating industrial facilities. I understand that many of the industrial facilities, they run like what we call the old school belts, but there are many of them that they have now arms like that. But because we are agnostic on the hardware, we can work with robotic arms like ABB, that's the big one monsters that you see in big factories, Universal, KUKA, FANUC. We adjust to the arms that exist out there. And the goal is maybe not only to make the existing robotic arms smarter, but potentially go and show them that a job that's being done by a human being can be done by a robot because you can get the same efficiency. And we've seen we don't need to replace human beings. There are many jobs that human beings don't want to do because they can be dangerous, they can be very tedious. You're looking to operate in a clean environment that you don't have any germs. So definitely there is a lot of opportunity in that space, and we explore all of those. Yeah, thank you for the question.
Thank you.